I can. All right. The one by the phone, please. All right. So today we're doing more parametrics. Let's just warm up for the 4 people, I think, who were gone yesterday. Oh, wait. Let's warm up first with some quiz review. Complete the square, identify the conic, and find the eccentricity. Who's got the first one here? Okay. Okay, I got enough room. What do you know? All right, now what? Good job. What is that? Then? So we get x minus 4 quantity squared over 1 plus y plus 5 quantity squared over 4 equals 1. Conic. Eccentricity is going to be c over a. It is an ellipse. Okay, this is where we got a little foggy. There's a different definition of a for an ellipse than there is for a hyperbola, right? There's also a different definition of how you find c. So how do we find c when it's an ellipse? Okay, and which of those is a squared? The bigger one. So a squared is 4, b squared is 1, c squared is a squared minus b squared, which makes c square root of 3. So eccentricity is over 2, right? Because a was 2, not 1. Everybody good? All right, what about this guy over here? I'm just listening to what Hunter tried. Yep, go ahead. You want to take a 2 out or move them to the other side? Okay, so when we move it over there, we'll have this. Now what? Take a 2 out over here. Six, which makes this 72. And then if we wanted the form that was on our sheet, we would divide the 2 over here, so it would become a what? One half, yes? Anybody awake out there? So that is a whose eccentricity is always, which is it? The circle is 0. And this is 1. It is defined as 1. All right. Sorry. So again, our learning targets, make sure we can graph these and identify the endpoints and understand where the restrictions come from. And we can write eliminate the t by putting one into the other, substituting in, and then do all kind of projectile motion equations that find things that they want. All right. If you want to use your calculator to do this one, that's fine. But I do want you to be able to do the chart. So you don't have to do the chart by hand. You can do it on the calculator if you want. What do I need to do first? Turn my calculator on, put it in parametric mode. It is going to need to be in degrees later. For this question, it wouldn't matter. Okay, then I go to y equals, and I do what? What's the x rule? T, square it, and then subtract 1. And the y rule? 2t plus 5. Then what? This is really important, right? What is this telling us? Okay, and what about the window? Yes, the t min is -3 and the max is 1. So if we were making a table and doing it by hand, we probably would have gone -3, -2, -1, 0, and 1. All right. I'm going to change my x. We always leave our t-step 0.1. I'm going to change my x to like -10 to 10 and my y to -10 to 10 because that's what the graph paper is, right? So even if that's too big, it'll fit on there, and that's fine on the quiz as well. All right. If I look at the graph, I get a, I don't know, a Nike symbol? I don't know, a half of a shepherd's hook? I don't know. Anyway, I can go to the table and fill this in from -3. Okay, I got 8, -1, 3, 1, 0, 3. I can't read those guys. -1, 5. Did I get it right? And 0, 7. Notice the table goes beyond where the t-steps, right? The graph shouldn't, though. The graph we defined is only going to go from -3. So if we do trace at -3, we get 8, -1. That is an endpoint. And then if we trace out until, yes. Did you put the right rule in for x and the right rule in for y? Because if you flip them, it will go the other way. Is someone else's going the way mine is? Maybe I have something in wrong. No, mine is. All right, I'll come. Look, 1 second. I was trying to trace out until t was 1 and make sure we got 0, 7 as the other endpoint. All right, so fill that in and graph it on yours, guys, while I check what's up. Yep. Anybody else have a question? All right. So it was here somewhere. I'm not even bothering. And it went -3 to 1 here, 8, -1, 0, 7. We just did -10 to 10. All right. Eliminate the t, though. Can we finish that part? Which one's easier to put into the other one? Yes. easier to put this one in here, because if we get the x, this t by itself, then we're going to have a square root with a plus or minus, right? So if we make the y equals 2t plus 5, can someone explain to the people who are gone what we're doing? We're going to isolate the t so we can substitute it into the other equation so that we only have x and y left. So if we rearrange this, it will say y minus 5 divided by 2, yes? Okay, now I have t by itself, and I want to put that into the other equation, so it'll say x equals, instead of t, I'm going to write that mess, okay? And it's all right with me if you leave it that way. If you left the top squared like that, okay, right? If you squared the 2 on the bottom, you'd get a 4. If I added the 1 over to the other side, and then to get rid of that divide 4, I multiplied it over here. You don't have to do this. The original one is fine. But this is the equation from last week, right? The form we used last week of a sideways parabola whose vertex is at -1, 5. Does that look right? Clearly on my picture it's at -1, 5. Okay, maybe not. Are we good? All right, we have something new today. We need to, you know what, all right, we'll graph this in a second. Let's talk about it first. Oh, maybe it's more fun to just graph it and be surprised. All right, so on your calculator, I want you to go to x and type in 2 cosine theta, or 2 cosine t. Okay, 2 cosine t. And into y, right here, mine says 4 sine t. So in y, I'm going to put 4 sine t. Now, I think we should do these in radians. It really doesn't matter, but I'm going to put my calculator back in radians. Told you to put it in degrees a minute ago, my bad. And then I want to do a whole rotation. So instead of t, if I want to do all the possibilities, what would t be? Because we put that in for theta. In radians, what's all the 0 to 2 pi? We actually might want -2 pi to 2 pi. Let's do 0 to 2 pi and see what happens. So 0 to 2 pi, I'm leave my t-step 0.1. I think I'll leave -10 to 10 and -10 to 10. We might want to zoom in a little bit, but let's see what happens. What did we get? It looks like in a circle. Is it actually a circle? If you did that zoom square where it, you would see that it's actually, because zoom square takes and makes the scale the same both ways so that it's not stretched. It is an ellipse, okay? It's going 4 up, 4 down, 2 left, 2 right. Okay, now, some of us could easily write the equation of that after seeing the graph. But the idea is that we're supposed to be able to substitute this in. Can I explain that to you? Do you remember when you did stuff like this, remember, and you multiplied this one by -2 and then you added them together because you wanted something to drop out, all that good stuff? Okay, we're kind of going to use that idea. Up here it says x equals 2 cosine of theta and y equals 4 sine of theta. Okay, I don't know how to get rid of cosine and sine. Guys, this is like magic. You need to be paying attention because later on when you think about this, you're going to go, I have no idea how to get rid of cosine and sine. You can't do like an inverse cosine or something. It's not going to get rid of it altogether. What we're going to do is we're going to divide by 2. on this one and divide by 4 on this one. Now I have a cosine and a sine. If I square both of those, both sides here, that's legit as long as you have an equation and you square both sides. So what happens to the left side? X squared over 4 equals cosine squared. You good? When I square both sides of this one, what happens? Y squared over 16 equals sine squared. Now, why was that a good plan? Remember I said something about adding them together? What happens if I add these together? Cosine squared plus sine squared equals 1. And if I add the left side, I got to add the right side. So I get x squared over 4 plus y squared over 16 equals 1. Is that the equation of that thing we just graphed? Okay, like I said, it kind of just feels like magic, right? Because it's like, how did you... But that's like the proof of it. Okay, that's why it equals 1, because cosine squared plus sine squared equals 1. All right, let's try these. These are pretty easy. Same pattern. What are we going to do here? X over 3 equals sine. Y over 2 equals cosine. Then what are we going to do to both sides? So it will become x squared over 9 equals sine squared. And this one will be y squared over 4 equals cosine squared. And then if I add the left sides and right sides, I get what? X squared over 9 plus y squared over 4 equals cosine squared plus sine squared, which is 1. Can you try this one? Anybody have an equation? Does it matter the order we have those in? It's plus, right? So if you put x squared over 25 plus y squared over 16 first, we're all good. Okay. It's easy until you don't do one for a while, right? And then you kind of look at it and go, I have no idea what to do with that. So practice that a couple times so it doesn't fade away in your memory. All right. I just want to talk real quick about inverses because this is a property of parametrics that's important later in calc. If I graph this, okay, it says to graph this with a negative 10 to 10 window, which I originally had, but I messed it up, I think. 3t minus 1 and t squared plus t. Oh, it says to use negative 10 to 10 for a t window. Gotcha. Negative 10 to 10 for the t window. I'm going to go ahead and do negative 10 to 10 for my x and y too. All right. Anybody get something like that? All right. Then it says to do a zoom square. Still goes off the top though. All right. Anyway. Does anybody remember what an inverse is? Inverse switches the x and y's. Anybody know how we're going to do an inverse in parametrics? How? So what are we going to type for this x? Oh, you guys are geniuses. T squared plus t. And for the y, we're going to put 3t minus 1. Okay. Now, I'm going to, if you have different colors, you're really lucky. I'm going to do this one darker. So there's the first one and there's the second one. Do you remember what the definition of inverse was in terms of a graph? The graph should look like it did what? Reflected over the line y equals x, okay? The line through here, y equals x. Do you see that it's a reflection? And we didn't have to do anything except switch the rules, right? So it's kind of cool that inverses work that way. All right, it says do the same thing here. Oh, I didn't draw the sketch. So this one was a parabola over here, and then this one was a parabola down here. And they reflected across that line. Ooh, that's really bad. I don't even know what that is. Anyway. All right, so do this one real fast and draw a sketch for yourself. How's that? It's nothing very exciting, right? But wherever this started here, and it went this way, and then it's starting down here, the same y value and going this way. Looks like inverses, yes? Okay, they are symmetric across, reflected across the line y equals x. All right, that's not on the quiz, but it's great fun. Okay. The inverses isn't, I know, it's easy, we should do it, right? To model the actual path of a ball thrown straight up with the initial velocity of 90 feet per second, starting at a height of 5 feet, we're going to do something a little bit weird, okay? We're going to put this in the calculator. Now, I'm going to go in here and clear out these x's and y's that we just graphed. Okay. Now, this is weird. Everybody knows where this came from. Negative 16 squared plus 90 t, negative 16t squared plus 90t plus 5. Initial height of 5, initial velocity of 90, right? The equation we did at the beginning of the year. This x equals 8, guys, is a random number I picked because I want it to go out and just be a vertical line at 8. And I'll show you what happens here. So it says to make x 8, not 8t, just 8, and then y negative 16t squared plus 90t plus 5. All right, and then what does it say to do? Gives us some more information. It says to use 0 to 6 for our t. Okay, make sure you're doing this. Set your t window, in the window, t 0 to 6. And then it says for x, leave the t-step point 1. For x, use 0 to 10. Leave the scale 1. And then for y, it says use negative 10, I'm sorry, for your min to 200, which means you could change your scale. I'm just going to be lazy and leave it 1. All right. This is going to be the most boring graph ever, okay? Okay. Does anybody remember how we turn on the bouncy ball? Okay, go right here in front. So on this one, I'm going to arrow to the left. Okay. And I want it to actually trace the path. So I'm going to hit enter a couple times till I get this one that looks like a -0. And then when I hit graph, this is the path of the ball. Now, that doesn't seem that exciting. Okay. I want you to watch mine on the screen one time. I'm going to turn off the path this time just because I want to do some. It's just going to show the ball. Everybody, eyes up here for a second. I want you to think about the speed at which the ball is moving. What does it do as it gets towards the top? Slows down. And what does it do as it approaches the ground? Speeds up. Is that what really happens? Yes. Okay. Now, that's an actual path of a ball if we threw it straight up, and that's the speed at which it would move, okay? Now, I'll show you something really weird. If we go down here and we put in t as x, and then in y we put the same thing, -16, I'm sorry, I didn't type that right, t squared plus 90 t plus 5. I think this is going to work. We could turn the, I'm going to turn the path on with a little -0 for both of them. And then what happens if I do it right? I don't have it turned on right. If you go to mode, guys, you want it to be simultaneous, not sequential. You want it to be doing it simultaneously. So then when I do it, it should show the path of the ball at the same time it's showing the parabola we're used to seeing. Okay, just kind of cool to see it at the same time. All right. I'm going to skip this question. It's just like for fun. If you type this in, you see this thing going across the screen and it's like the path of a ladybug, but I would rather do the applications that are on the quiz, okay? I'm going to go back to worksheets from yesterday. Real quick, did you write down the rule for Luigi when we got to this problem yesterday, anybody? Off the sheet, right? It's actually on your green sheet. Everybody find it on there? Mine's not green, but it's under the hyperbolas. Do you see the box that gives you the formulas? Okay. What does it say for x? T times initial velocity, which was 35, yep. Times the cosine of 48, and we need to be in degrees, right? We need to remember that in a minute. And for y, yes, because it's feet, the gravity factor is the -16t squared. If it wasn't, I would tell you that on the quiz, okay? I'm just going to do it in feet on the quiz, but I think there's one on the homework that might have to use -9.8 for meters per second. And then plus t times 35 times sine of 48. Did this have an initial height? This one was 2 feet off the ground, okay, when he kicked it. I don't know why, but it was. Okay. When we went to type this in, we had to pick our own t. What is t representing here? T is time, okay? So we could put t in as big or as small as we want, but can time be negative? Not generally, right? I didn't put mine in degree mode yet. All right, so if t is time, it's how long till the ball hits the ground. A soccer ball isn't in the air very long, okay? You can put 3 or 4 seconds and probably be fine. How will you know if you didn't put enough time in? The ball will stop in midair, okay? Then you'll know, oh, maybe I need that path to continue a little further. All right, I can't, X is the distance horizontally away from me. How far do you think a soccer ball could fly? Okay, so let's try 90 for the max. Y is the height, okay? I don't know, 30 feet in the air, what do you think? Okay. My window's too big, but will it work? Yes. Okay. So it was far enough to hit the ground, so I only did 3 seconds. You can have a little more if you want. I might change this to like 50 and 20 or something. All right. Now, there are multiple questions I can ask you guys. The problem is there's some of them are very hard to get exact answers for. If I asked you how high was the ball after 2 seconds, could you do that exactly? You'd just trace until t was 2, right? And you'd say at 2 seconds the ball was underground. All right, if I said 1.5 seconds, you could tell me. But if I ask you how far away does the ball hit the ground? Okay, how far horizontally did the ball travel? What do I want? How do I figure that out? Trace, and I want what to be 0? The y. Can I get the y to be exactly 0? No, because I can't control anything except t. All right? Now, at 1.7, it's pretty darn close to 0, right? So I could say the ball went about 40 feet away, 39.8. Everybody with me? The only way to make that any more accurate would be to try to type in a value of t that we think would make it better. Like if I did 1.69 for t, yeah, that's not good. 1.699. There, that's even closer to 0, right? But is it still about 40 feet away? Yeah, I'm not worried about it. All right. Step 4, find the time the ball hits the ground. So the height is 0. What did we say the time was? About 1.7? Is that right? Travels about 40 feet. More questions. How high did the ball get? So can we answer how high the ball ever got? There's not a way to find a maximum, okay? If you go second calculate, look at these. dy dx, dy dt, and dx dt. Those are derivatives for calculus. We can't do any of that yet. So we just have to guess by tracing along. If I want the highest it ever went, make sure you're tracing. But what am I looking for? The highest y value, right? The highest y value. You can't do maximum. About 12.6 maybe? Nope, you're going to have to just estimate with this. Will it clear a 6-foot defender standing 35 feet away? How can we tell that? We want X to get close to what? 35. There's pretty close to 35. The Y is not above 6. Looks to me like it's going to nail him right in the head. What do you think? About 5 foot? Unless he heads the ball, because it is soccer, right? But the only way to get that even closer would be to like type in 1.48 maybe. Okay, 1.49. You don't have to do this. If you wanted to figure out where it was at 35 feet away. What was 1.5? Anyway. There's 35.0 feet away, and it's about 5.1. It was fine without me fiddling around. Okay, more practice. Julie's throwing a ball at an initial velocity of 28 feet per second and an angle of 56 from the horizontal from a height of 4 feet. How far away will the ball land and how much time it takes till the ball lands? Okay, tell me what to do. There's 3 things that are going to be on the quiz. What you typed in for X and Y, what window you used, and then answer the question. Okay? And the window will say T, X, and Y. I didn't ask you to do a sketch, but. So what am I going to type in for X? Okay. 56, is that what it says? Okay. And then for Y? Anybody? Yeah, somewhere you got to put a T in there and a 28 and a sine of 56. And this one says 4 feet off the ground. Further, higher, what do you think about our window? I'm just going to try it from the window we have. It's not bad, right? Works in the window we have. I suppose if I was on a quiz or test, I don't need more time. It definitely hit the ground. I could go more like maybe 30 and 15. I don't know. Does that still fit? Oh, that's nice. All right, so I did, it'll say T and have a blank for you to write in the window. And I have 0 to 3. And then it'll say X. I have 0 to 30. And Y, what did I have? 0 to 15 maybe? Okay, what about the questions? How far away will the ball land? What am I trying to do? Trace and tell Y is close to 0. Looks like about 0.18 is close I'm going to get. And it's how far away? 25 feet away? Someone else get that? Okay, and then what? How much till it lands? About 1.6 seconds? Who's having trouble? Did you figure out what you did? No? Okay. Yes. For my choice, you just want to make the ball land. Okay? So if I put in 1 second, this is what would happen. It would stop in midair. You can put in a lot more, but your calculator is trying to keep graphing. Like if I put in a T max of 20, my calculator's thinking, because it's trying to keep graphing. And so I just want to put in as little as I can, that it'll still hit the ground. But if you put 5 or 6, I would not count it wrong at all. Okay? Great questions. Anybody else? All right. This one's fun. Jerome hits a tennis ball, 38, angle of 42. From a height of about 1.5 feet, right? Okay, then there's all these other questions, but let's get this typed in. Okay. I'm thinking my window is not going to be good. No. 0 to 50 for X is better. Okay, perfect. So it's still hitting the ground. If I leave T, X, Y, was it 15 I had for Y? Anyway. Okay, how far away will the ball land if it's not hit by his opponent? So when Y is close to 0, it's between 45 and 48 feet, right? I could do 1.65. That's pretty close. It's about 47.5 feet. You put anywhere probably between 45 and 47 or whatever it said a minute ago, I'd be okay. .6 I'm going with because I got it kind of accurate, but doesn't have to be that close. Okay. The rest of the question, though, says, what is the approximate height of the ball at the net if he was standing 20 feet away from the net? So, what does that tell us we want to know? Want to put in what? He was 20 feet away from the net, so that's what? Horizontal or vertical distance? We want the X to be about 20. 0.7 is as close as I can get. 0.7, if I type a 0.74, 0.73, I could get closer, but close enough. So 0.71 puts me 20 feet away. How high was the ball? I really don't care that you're that accurate. 11.5 feet, something like that. Okay. I'm out 12 feet at net. So I'm not thinking they're going to slam it on him if he's playing doubles, right? 12 feet is going to go over everybody's head. All right. On today's, we didn't get to this one or this one, or we didn't get to play around with these, but you should be able to do everything on the assignment now, okay? These are fun. You can try typing these in. I gave you some hints here if you want to try them. But those are just for fun. They're not on the quiz. Yes. Can you? Yes, absolutely.